Okay, so now that we graphed quadratics and we solved by graphing, we want to talk about other ways to solve equations. So the first thing that we have to do is we have to review how to factor. So remember that the factored form of a quadratic is where you can factor it into the linear factors. And so it says this is the factored form where P and Q are the x-intercepts of the graph. And so I should have covered some of this up, but oh well. So if this is the standard form of your equation, if you factor it, and we're going to go over how to do that in a minute, you would get this, x minus 6 times x minus 2. And then you could solve each one of those and get x equals 2 and x equals 6 as your x-intercepts. So notice that the factors lead us to those things that we found by graphing yesterday. And so remember that basically factoring is undoing the FOIL method. If you remember, how do you multiply these? We usually teach you with FOIL where you do the first. So x times x would be x squared. X times negative 2 would be negative 2x. Negative 6 times x would be negative 6x. And negative 6 times negative 2 is positive 12. So that stands for the first. That's this. This was the outside terms. This was the inside terms. And this was the last term. So that's where that term FOIL comes from. And then usually you can add the OI together. That's what I say. So negative 2x minus 6x is negative 8x plus 12. That's how we multiply it together. What we want to do is factor it. So when you factor it, you have to go back and think about what multiplies to give you the last term, that adds or subtracts to give you the middle two terms, because that's where this comes from. Okay? So your book goes over this, how to factor this. But the first thing they talk about is working backwards. It says write a quadratic equation in standard form with 1/2 and negative 5 as its roots. So remember, roots means it's zeros. So this means that we have roots at negative 5 and at positive 1/2. So we want to go backwards and go from the answer to the equation. So think about if I wanted to move this back over, I would just add 5 over here, and that would be the factor x plus 5. And the same thing on this one, but normally we don't have fractions in our answer. So instead of getting a fraction, I'm going to multiply by 2, and that would give me 2x equals 1. And if I subtract the 1 over, that would be the factor 2x minus 1. So if I'm going to write an equation, I need to write y equals x plus 5 times 2x minus 1. That would be the factored form. But since it says in standard form, that means I want to multiply it out. So that would be 2x squared. X times negative 1 is negative x. 5 times 2x is 10x. And 5 times negative 1 is negative 5. So simplifying that all out, I get 2x squared plus 9x minus 5. And if you graph that, it would cross at 1/2 and negative 5. Okay, so we're going to keep practicing that throughout this chapter, being able to work backwards. But the majority of this section is talking about factoring. And so these are kind of the basic 4 ways that we factor quadratics. One of them is just the GCF. So if I have x squared minus 3x, the GCF is the greatest common factor. And I would say I could factor an x out of those, kind of undoing the distributive property. And what would be left from that would be an x. And if I take an x out of negative 3x, I would be left with negative 3. General trinomials is when we undo FOIL. I don't really have a good example of that, but that's just where we're going to rewrite it as 2 parentheses. And then we have some couple special ones. The difference of 2 squares is like a squared minus b squared. That factors into a minus b and a plus b because you get nothing in the middle. And then perfect square trinomials, I don't really recognize this very often, but if you have a plus b times a plus b, every time that FOILs out to be a squared plus 2ab plus b squared. So if you notice that the front and the back are perfect squares, that might be a perfect square trinomial. So let's just practice. That's basically what we got to do here, is just review a whole lot of stuff. So first thing is you want to look, and you should always look for your GCF first, and then maybe there's something else to do. But right away in this, I see a GCF. What's a common factor in all of these? I could take a 3 out of all of these, and I could also take a y out of everything. And when I say take out, that usually That means divide out, right? So if I take 9 divided by 3, I would be left with 3. And if I take 1y out of y to the third, I would be left with y squared. If I took a 3 out of negative 6 dividing, that would be negative 2. And I took 1y out, so I have 1y left. And 3y divided by 3y is not 0, right? We're dividing, so that would be plus 1. And then we could try to factor this, but we're not factoring those today. But that's not even factorable, so that would be our answer. That is just a GCF. This one is 4, and I don't know, maybe that one didn't have that one. This is going to be factor by grouping. And I think once I do this one, hopefully it'll jog your memory on how to do this. If I try to take a GCF out of this, they don't all have any of the same factors. They don't all have a factor of 2. They don't all have a factor of 5. They don't all have an A, and they don't all have a B. But what we can do is we can group them together. So what if I just group the first 2 together, and I group the last 2 together, and do the GCF of each one? So on this one, what could I take out of both 8 and 10? I could take a 2 out of those, and I could also take an A out of that. And so what would I have left? Dividing, I would have 4A, and 10 divided by 2 is 5. I took out the A, but the B squared is still there. And if I do the same thing over here, 4 and 5 don't have anything in common, but what I can do is I can take 1B out of that. If I take the B out of this, I'm left with 4A. And if I take 1B out of that, I'm left with 5B squared. Here's how you know when factor by grouping works, is look at these 2 parentheses that are left. They're the same. So now we can take those out. So you take out the part that's the same. And if you take that out, you're left with what's on the outside, 2A plus B. And that is what that factors into. That's going to come into play later, so hopefully you kind of have some memories of that. And then the last big idea here is factoring, like undoing FOIL. And so first of all, number 4, what do you notice? They all have a B in them. I also could take a 6 out of all those, so I think I could take a 6B out of this, and I would be left with what? 4B squared minus 3B. 18 divided by 6 is 3, and I took the B out. And then so that's just another GCF one. Now look at number 5. Number 5 is our undoing FOIL. And so when we undo FOIL, we're trying to write it back as the 2 parentheses that multiply to give you this. So this is your F of FOIL, this is your L of FOIL, and then the middle term is the combined outside and inside. So when you do this, you want to think, what multiplies to give me x squared? Well, it's just x and x. And then your job is to think, what multiplies to give me 25, the last number, that adds to give me 10? And so 25, the only thing that multiplies to give me 25 is 1 and 25, and 5 and 5. So 5 and 5 are my numbers. And if I want to get 10, the only way I can get positive 10 is if it's plus and plus. And you can leave it like that. If you really wanted to, you could write that as x plus 5 squared. Let's do some more. What about this one? Well, this one, there's a common factor, right? There's a GCF. I could take a 3 out of this, and 12 divided by 3 is 9, b to the 8th. And if I take a 3 out of 27, that would be 9c squared. This was kind of tricky, but I think this is a perfect square and this is a perfect square. So think about factoring it again. What multiplies to give me 9 is 3 and 3. And what multiplies to give me b to the 8th? Well, when we multiply, we add the exponents. So that would be b to the 4th and b to the 4th. Same thing at the end. What multiplies to give me 9c squared? Well, 3 and 3, and then c and c to get c squared. And this is a difference of 2 squares. So how do you get nothing in the middle? It means one of these has to be a minus and one of them has to be a plus. And if you multiply this all back out, you'll get back the original problem. We're just rewriting it to solve it later. That's why we're doing this. Okay, what about this one? Again, today we're kind of focusing on undoing FOIL when there's nothing in front of this. The next day is when there is something in front of it. What multiplies to give me z squared, z and z. What multiplies to give me 36 that adds to give me 12. And if you're someone that struggles with factoring, think of it starting at the last number and working this way. What multiplies to give me this number that adds to give me this number. And if you can't think of it right away, think of all the things that multiply to give you 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And the only one that adds to give me 12 is 6 and 6. So this has to be 6 and 6 again, plus and plus. Oh, how many more do I have here? Oh my goodness. Okay. What about this one? I think I'll stop here and we'll do the other ones in class. What'd you get on this one? Well, again, what multiplies to give me x squared is x and x. Now I want to know what multiplies to give me 24, and this is important. I'm subtracting to get 2. So think of all the things that multiply to give you 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. What's the only one that when I subtract I get 2? The only one is 4 and 6. It doesn't matter where you put the 4 and where you put the 6, but what matters is what signs you put on it. Which one gives you positive 2? Is it 4 minus 6, or is it 6 minus 4? Well, since it's a positive 2, it has to be this one, because this equals negative 2. So that means that the 6 is positive and the 4 is negative. And if you FOIL that back out, you'll get back the original problem. So if there's a couple more left on here, why don't you try them and see what you get? And that's what we'll start in class tomorrow.